Hi everyone. Welcome to chapter 6. This is a exploration of exponential functions. This is a really fascinating topic, particularly now because COVID has many features that are going to be modeled with exponential functions. So we're going to see some applications to that. But when you get done with this lesson, there's some things I want you to be able to know how to do. I want you to know how to evaluate an exponential function. That's pretty simple, plugging in. I want you to be able to find an equation of an exponential function. So that may mean having data or points and coming up with an equation that's exponential. Now that's going to correlate to solving. And this is something we're going to have to learn. There's a little easy algebra skill that some of you may not be familiar with. And I also want you to be able to evaluate exponential functions base e. And I want you to be able to use and solve exponential functions that are continuous. And we're also going to look at compounding interest formulas, which are also exponential. So that's our game plan here. All right, so we're going to look at exponential functions, and we're going to keep adding layers to them. I'm going to start off looking at it very intuitively with just the graph and draw out one particular aspect of an exponential function. So here we've got our exponential function, and we could plug it into the calculator and get a bunch of points and plot points. But a couple points of interest would be 0. So if we plug that in, we have to calculate 2 to the 0. And 2 to the 0, any base to the 0 power is 1. And then, of course, 1 would be 2 to the 1 power, which is 2. And then 2 to the second power, which is 4. And 2 to the third power, which is 8. And so we get there is 0, 1, 1, 2, 2, 4, and then 3 is way over here, and 8 is way up at the top. But that's not the main thing I want to focus on right now. What I want to focus on is the tails. It has 2 tails. Now, in polynomials, our tails are both at positive infinity or negative infinity. And typically with the rational functions that we just finished studying, the tails would have been usually on a horizontal asymptote. So they're not at infinity, they're at some number. But this exponential function has one of each. One tail, the y is going to infinity, and this tail, y, is going down to 0. So we have some end behavior, but particularly on this half, we're seeing the evidence of something we've studied before. We're seeing the evidence of a horizontal asymptote. But unlike rational functions where the branches hit the horizontal asymptote generally on both sides of it, this one, the exponential function hits the horizontal asymptote only at one side. So let's summarize what this tail behavior... let's summarize first of all the asymptote. Exponential functions are going to have horizontal asymptotes. And this really basic one, its horizontal asymptote is at y equals 0. Now as far as the end behavior goes, let's describe that as x goes to infinity. So here my x's are getting big, the y's are going up, then y is going to infinity. But on the other one, as x's are going small, so as x goes to negative infinity, then y's are going down to 0. So now we've described the tails or the end behavior of this exponential function. And so the asymptote is really effective only on 1/2 of the exponential. Just one of the concepts or situations involving these exponentials that I want you to be familiar with.